Okay, so that's going to be a short video about the topic of electric circuit and questions you might have for the mcat. So as usual, you can pause the video and try to do them. So this is a typical question. So they talk about voltmeter and ammeter. So ammeter, amps, comes from amps. It's to measure the current. Voltmeter is to measure the voltage. So voltmeter have to be across a load, but the ammeter has to be part of the circuit so you can measure the current. So for example, if you have here you have a voltage here, and maybe you have a load with a resistance R1 and then another load R2. So if you want to measure the current in the circuit here, so this is the current. So then you have to place your ammeter as part of the circuit. Okay. So because you don't want to influence the current flowing here, so then the resistance of the ammeter has to be almost zero. So ideally it's equals to zero. In reality, it's very small. And then if you want to measure the voltage, so then you place your voltage here in parallel with your load. So you can find the voltage across that load. And you don't want that voltage to be like a short, right? You don't want current going through here. So you need a very, very large resistance. So for the voltage, the resistance should be infinite, ideally. So let's go back to the question here. Ideal voltmeter have infinite resistance, ammeter have no resistance, so you don't interfere with the properties of the circuit. Okay, so let's do this one. This one, it's an easy one. So again, you should pause the video and try to do it. So we have so you have a circuit in parallel. So this branch is in parallel with this one, but those loads here are in series. So again, this is an easy one. So you have 6 and 6 ohm and 6 ohm and 6 ohm. So first of all, you go always from inside out. So here you have your power supply. So you can replace that by one single resistance, which is 18 ohms. And then this one is 6 ohms. So now you have two resistances in parallel. So the equivalent resistance will be 1 over 6 plus 1 over 18, which is 3 over 18 plus 1 over 18. So you have the equivalent resistance, which is 18 divided by 4, which is 9 divided by 2, which is 4.5 ohms. So you can replace this by one resistance here of 4.5 ohms. So that will be answer D. So here it's about the plate capacitor, and you want to make the electric field strength between the plate of the capacitor stronger. So of course you could decrease the distance between the plates, but this is not a solution here. What can you do is adding a resistor will not do anything. Increasing the distance will decrease the electric field. Connecting an additional battery, so in that case, you're going to increase the voltage, okay? And so if you increase the voltage, then it's like increasing the pressure that will push the charges in the capacitor. So yes, so answer is D. You can also remember that the electric field, so you have a plate here, so you have plus, 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 minus, minus, minus. You have an electric field in between the plates here. And if you add a battery here, you're going to increase the voltage. So you have more voltage here. And the electric field is the voltage across the plate. So that will be that voltage here over the distance between the plates. So if this is going up, that will go up as well. So answer is D. So this applies to Kirchhoff law for current. So at the intersection here, the sum of all the currents will be equals to 0. So it's just a matter of simple algebra here. So we have to decide. So we want to find the current here. So we can say if it's leaving, we can decide that if it is leaving, the current is going to be negative. If it's coming, it's going to be positive. You have to decide. And the sum of all the current at P will be equals to 0. So this is leaving, so it's a minus, so minus 6. This is leaving, so minus 5. This is going in, so that will be plus 2. That's going in, so that's going to be plus 3. Going in, plus 8 plus I equals 0. Right, so leaving minus 6 minus 5 plus 2 plus 3 plus 8. Right? So that goes away. And then we have 2 plus I equals 0. So the current equals minus 2 amps. So minus 2, it means it's leaving. So that means it goes 2 amps. So it's leaving. Okay? So this one is a little bit challenging because you should not confuse power, which is energy consumed or delivered per second, and energy. So energy does not, it's over time. So energy will be power times time. So you can pause the video and try to do this one. So we have a square function here. So the current will go 2 amps for 2 seconds, and then it goes 0, and then it goes another 2 amps for 2 seconds. But energy is power times time. And the power for resistance is Ri squared, and R equals 10 ohms. So it says, what's the energy converted to heat after 5 seconds? So 5 seconds, I'm only look at this, right? So I'm only interested in this and that. So the power delivered by this is R. So 10 times I squared, which is 4. So that will be the power here. And the power here, so here nothing happened. So that will be 10 times also 2 times 2 is 4. So that will be the power here and the power there. So R squared. And then for the energy, so for this part, I need to multiply by the time, which is 2. And for this, I need also to multiply by the time. So the total amount of energy will be 80 plus 40, which is 120 joules. So the answer is this one. So a little bit tricky. Okay, so let's go to the next one. So you need, sometimes they give you the equation for the energy that you store inside the capacitor. So again, you want to pause the video, but sometimes they give you the equation. So you are storing energy. That's the amount of energy. So you look at the unit. So you know this is the energy. And this is the voltage applied across the capacitor, and it has some resistance. What is the charge? So the energy, and sometimes energy is called capital U. So the energy, one equation is 1/2 capacitance V square. Okay, that's the easiest way, the easier equation to remember. And you have C. The capacitance is the amount of charge per unit voltage. So if you plug that into this one, you have the energy equals 1/2 Q times V. So 400 equals 1/2 Q. And here you have 7,500. And remember, you cannot take the calculator, so pause, bye. So here you have H equals Q times 75. So Q equals 8 divided by 75. So if it was 80, you see 75 goes into 80, 1 something. You see 1 point something. But now you have 8. So it will be 1 point something divided by 10. Okay, because 8 is 80 divided by 10. So we look at, so 1 point something here divided by 10, which is 0.1 something. And the only answer will be this one, okay? So you don't need to do the calculation. You can look at the multiple choices, right? So that's the strategy here. So if you multiply the surface or the capacitance, so that's on the capacitance, the geometry. So the capacitance, it's a property that only depends on the geometry. So it's going to be proportional. So it's going to be proportional to the area and inversely proportional to the distance between the plates. So we are talking about a parallel plate capacitor here. So this is the area, and that will be the distance. So that means here the area is multiplied by 2, and the distance is divided by 2. Okay, so the new capacitance, so the area is multiplied by 2, and the distance is divided by 2. So it means that the capacitance, the new capacitance will be multiplied by 4. Because when you divide by 2, it's like you do this times 2, and then D times 1/2. So that's going to be times 4. Okay, so you divide by 1/2. It's like you multiply by the reciprocal. So A over G times 2 times 2 over 1. So the answer is this one, 4. Okay, so what about the next one? So here you want to find the, no, this one you want to find the, you want to find the voltage across here. So the across that resistance here, it's the same voltage across that piece here, which is in parallel, right? And the voltage is 10 volts. So you want to find the voltage here. And this is 10 volt. Okay, so let's see. This is, you have one resistance here, so that will be 1/2 ohms. And here we want to replace it by a resistance. And 1 over R will be 1/2 plus 3 over 2, which is 4 over 2, 1/2. So the equivalent resistance will be 1/2. So that's going to be 1/2 ohms. And this is 10 volts. The resistance is the same. So the voltage here will be 5 volts. And the voltage here will be 5 volts. So the answer is 5 volts. Okay. And then next one, it's a weird question. So you have 100 volts connected to 2 ohm resistance. So electrons, the current, the definition of current is the amount of charge per second. So let's find out the number of charge. And then here it says that you have 9.65 10 to the 4th coulomb per mole of electron. So you can pause the video. They just something you don't learn in the lecture, but by reading it, you can figure this out. So you have the current will be voltage. So using Ohm's law, V equals RI. So the voltage, and then the resistance, you have 2 ohm resistor, so divided by 2, which is 50 amps. Okay, so 50 amps, so that means 50, by definition, the current is the charge per second. So this is in coulomb and this is in seconds. So the unit is amps. So that will be 50 coulomb for 1 second. So for 10 seconds, it says here it's going to be 500 coulomb. Coulomb. So the charge is 500 coulomb during that time. And you don't know how many mole of electron you have, but you know that you have 9.65 times to the fourth coulomb for 1 mole of electron. And this is question mark. So you have to divide, right? So the answer will be 500 divided by 9.65 times 10 to the 4. So this is 10 to the second here. So I have 5 times 10 to the negative 2 divided by 9.65, which is about 10. So that will be about 0.5 times 10 to the negative 2, which is about 5 times 10 to the negative 3. So we want a negative 3 here. So the only answer would be A. Right? So 0.5 times 10 to negative 2. Okay, so that will be the only answer possible. So let's move to the next one. Okay, I think I'm going to stop here, and I will do a second video